we know that if I heat an object, it is going to give out some kind of radiation, right? Like a flame, for example, or a piece of hot metal. Now, if I take this hot metal, so let me take an incandescent light bulb, which is basically nothing but a heated tungsten filament, right? And that's giving out some radiation in the form of light. If I take this light and pass it through a prism, and I keep a screen behind, what will I get? I'll get a continuous set of colors, right? Or a continuous spectrum, correct? Something like this. Now, if I change the source to a fluorescent lamp or a mercury vapor lamp, and then perform the same experiment, I find something very different. On the screen, I find only certain wavelengths or certain colors. But in the previous case, I found a continuous spectrum of wavelengths or colors. Now, what was the difference? In the first case, I heated a solid, a tungsten filament. In the second case, I was heating a rarefied gas, in the case of a mercury vapor lamp or a fluorescent lamp. So when I heat a rarefied gas, I get only a set of wavelengths on my screen. And this spectrum, this is called the emission line spectrum, and these lines are called spectral lines. It was also found that this set of spectral lines was characteristic for a particular element. Or in other words, an element always produced the same set of spectral lines. Also, it was found that when white light was shined through this element, the spectrum that was observed did not have a few frequencies, or there were a few dark lines. And these dark lines corresponded exactly with the spectral lines that we saw in the previous case. This basically means when a gas emits some radiation, it emits only a few frequencies. And when light is passed through a gas and it absorbs some radiation, it again absorbs only few frequencies and exactly the same frequencies that it emitted in the previous case.